Hi everyone, in this tutorial, we're implementing an advanced damage calculation system. We'll combine character-based damage and resistance with weapon damage and resistance, resulting in deep, tactical gameplay. Everything is powered by Unreal Engine's gameplay ability system and fully customizable in blueprints. Let's dive in. Go to the Visual Studio and find RPG Character Attribute Set. We will add two attributes. One for storing characters' base melee damage, and another one for melee resistance. Character-based melee damage will be used alongside weapon damage to calculate the total damage dealt with each melee attack. On the other hand, melee resistance, both from the character and equipped gear, will be factored in to reduce incoming damage, making defensive stats just as important as offense. This is the common pattern how damage calculation system works in majority of games from RPG genre. Now open RPG Weapon Attribute Set and add Melee Resistance attribute to it. Now we have all the necessary attributes, it's time to implement damage calculation. For this purpose, we are going to use Gameplay Ability System. Create new C++ class as child of Gameplay Effect Execution Calculation class. This is the base class for implementing custom attribute calculation logic. Name it Melee Damage Calculation. Once created, go to Visual Studio and open header file. First, we need to define an empty constructor. Then we will override execute function. This function is defined as blueprint native event, so we need to override execute implementation. To make this calculation configurable from blueprints, I'm going to define a couple of blueprint native events. First one will be used to get damage magnitude. You can utilize it to implement different damage magnitude for light and heavy attacks. Also, it can be used for some more advanced scenarios like charged attacks. Next one will be responsible for getting attackers' weapon damage. Instead of getting weapon damage in C++, I would like to expose this function to blueprints, so you can easily define logic for getting weapon damage in blueprints only. The same goes with function for getting victims blocking weapon damage absorption. Now I will add two events that will be called when some damage is done or when damage is absorbed by the target actor. During this tutorial you will see how to utilize these events to implement attack blocking mechanic. Also, I'm going to define default implementations for last two events. Let's start with implementation. First, we are going to implement constructor. Before we start putting things in constructor, we need to include gameplay ability system and RPG attribute set. Also, we need to create one struct that will hold attributes we would like to capture from source and target actor when this calculation is invoked. In our case, for melee calculation, we are making capture definitions for base melee damage, melee resistance, and health attributes. Base melee damage we are capturing from source actor, or the attacker. Melee resistance and health attributes should be captured from target actor, or the victim. Additionally, define one static function that will simply return melee damage static struct. Now, in constructor, add base melee damage and melee resistance attributes to the relevant attributes to capture property. Before we start with implementation for execute function, I would like to make default implementation for this custom functions that will play a role in calculation formula. First, make default implementation for get melee damage magnitude. It should return 1. Following the same pattern, make default implementations for next two functions. Both should return 0 as default value. Now we are ready to implement calculation. First, use execution params to get source and target ability system components. Then use these components to find source and target actor references. Then use execution parameters to capture source and target tags. Now we need to get base melee damage from execution parameters. This should be attacker's attribute that is captured when calculation is invoked. For this purpose we will use function attempt calculate captured attribute magnitude in combination with base melee damage capture definition we created before. As we explained at start, attacker's weapon damage will be used in calculation too. For calculating weapon damage we should use blueprint native event, get weapon damage. Now we need to take care of defending attributes. Following the same pattern like for attacker's stats, we can get target's melee resistance and block absorption. Finally, damage is calculated using formula from the beginning of this tutorial. Also, you can see that damage magnitude is used to multiply attacker final damage before defending stats are applied. At the end, we should check if any damage should be done to target actor. If yes, apply a modifier to health attribute using execution output. Also, make sure to call on damage done event we defined. Since this function is constant, we need to use const cast. Keep in mind that constant functions cannot change class values, so it will be good that in the blueprint implementation of damage done event you don't change any values from calculation class. Lastly, add call to the event on full damage absorbed when no damage should be done because target actor absorbed it. One last thing we need here is to make sure that we have default implementations for last two events. Here I will only log some messages. I would like to give child blueprints freedom of implementing any logic here. When you finish with all the code, go back to Unreal Editor and compile. Now it's time to use the system in our game. But first, we need to make sure that new character attributes are populated with some values. Go to Character Attributes Data Table and add rows for new attributes. Also, make sure to add attribute modifiers and character attributes effect for new attributes. Now it's time to create melee damage calculation. First, create new blueprint as child of melee damage calculation class we defined in C++. Open it. On the right-hand side, you should see an array of attributes that will be captured when this calculation is invoked. These attributes are those we defined in C++. On the Functions section, you can see all the functions we defined in C++ that are available for overriding here. Let's start with getWeaponDamage function. The logic here should be simple. We need to get a weapon from source actor that is used to perform attack. For this purpose, we can use getEquippedWeapons function we have defined in Warrior interface. However, this function will return all the equipped weapons from the actor, not only one used for the attack. Here we will use gameplay tags to help us find the right weapon. I will add unique tags that will be used for right hand and left hand weapon attacks. Later, we will need to add exact tag when an attack starts. When we found weapon that is used for the attack, we can get its damage using ability system component that weapon actor has. Next function we are going to implement is getBlockAbsorption. First, we should check if target actor is trying to block incoming attack. To do this, I'm going to use unique tag that is related to my block ability. For the rest of the function, you should follow the same pattern like in previous one. Right now I will make an implementation that is using left-hand weapon as blocking weapon. If you have some more complex weapon system, like two-handed weapons, this function should be expanded in order to find the right weapon that is used by target. There is one more function that is used in calculation formula we need to implement. getDamageMagnitude. In this function I will show you how to handle different attack types with one calculation class. In my example, I'm going to apply different magnitude for light and heavy attacks. If you are creating combat system with some more advanced features, like charged attacks, only thing you need here is to provide a way to calculate magnitude. All the calculation logic stays the same. At the end, we should implement last two events we defined in C++. Let's start with event onDamageDone. This event is the right place to handle block broke logic. If target actor is trying to block incoming attack, but this attack deals damage to it, target actor should exit from block state since its block is broken by last attack. For this purpose I'm going to send gameplay event to target actor. Also I will define separate gameplay tag for this event. Event on full damage absorbed is used to handle another blocking state. If target actor absorbs whole damage while blocking, attack from source actor should be stopped. One more state that you can handle here is attacks that are able to break block. We implemented this logic in some of the previous tutorials. these attacks should have special gameplay tag. In that case, even if whole damage is absorbed by target, block should be broken, leaving the space for next attack on posture broken target. Finally, it's time to make usage of this calculation in gameplay abilities. For this system to work properly, we will need to make some changes in the existing attack and block abilities. I'm going to create new version of attack ability instead of modifying existing by duplicating it. Here we need to wait for attack blocked event in order to support attack blocked reaction. Previously, we did this in block ability. So you can go to block ability and find the code where we used immunity to block incoming attacks. Copy this 2 nodes and paste it in our new attack ability. For executing gameplay Q node, we need to provide target actor. Use avatar actor from gameplay ability for that purpose. Now let's change damage effect. It is defined in property gameplay effect to apply on target. Again, I will not change it, I will duplicate it and make changes to new version. Here you should delete all modifiers. We are going to use executions array. Add 1 element to it and select melee execution blueprint we have created. Now add toe calculation modifiers. We are adding 2 because we have 2 attributes that needs to be captured. Now go back to attack ability and use new damage effect. For heavy attack we should do the same. Duplicate it and change damage effect. Now we need to take care of block ability. Duplicate existing one and open it. Find this section where we are handling immunity. Delete all nodes except those for applying block broke effect. Instead of immunity, here we should wait block broken gameplay event. You can still have immunity to other effects during block ability, but melee damage is fully handled by calculation class now. Right now we should change gameplay abilities of our weapon actors. I'm going to do this only for sword and shield. Additionally, my shield doesn't have weapon effect that will populate initial weapon attributes. So I'm going to create new effect for this. One more thing we need to do is to assign right attack tag for left and right hand attacks. In my project, I have only covered right hand attacks for now. So I'm going to update that place. Before attack starts, you should remove all attack related tags. Then add appropriate tag to actor. In my case, this will be right hand tag. Now everything is ready for testing. You can notice that enemy cannot damage player right now. This is because player's melee resistance is high due to high character level value in comparison with enemy. But when player attacks, enemy shield will absorb some damage, but its posture will be broken. Let's change melee resistance for my player temporarily. I'll put it to be 0. This should be enough to allow enemy to damage my player. As you can see, player takes some damage from the enemy. Also, when player is just standing, amount of damage caused by enemy attack will be greater. But when I try to block incoming attack, damage will be reduced by amount absorbed with shield. Let's test full block and block broke reaction now. For this purpose, I'm going to increase shield melee resistance. As you can see, now player and enemy can block each other. However, when player uses block broke attack, enemy's posture will be broken, leaving it vulnerable for next attack. That should be it for today. I hope you learned how to utilize gameplay effect execution calculation and how to make it easier for customization and blueprints. If you want access to project files, they are available on my Patreon. Thanks for watching and see you in next video.